Hey, Brent class, today we're going to be dividing with fractions. Take a look at this situation. If Mr. Brandt had 5 feet of string and he needs 1/3 of a foot pieces of string for a project. So how many 1/3 of a foot pieces of string can he make from those 5 feet? This is a division situation because I'm taking these 5 feet of string and I have to divide it into 1/3 of a foot pieces. If we were to write it in an equation, it looks like this. So how would we solve something like this? 5 divided by a fraction, by 1/3? Well, let's look at a picture. A model is always helpful when you're trying to make sense of something new. So here are going to be my 5 feet of string. So I'll divide them into foot sections. So 1 foot, 2 feet, 3 feet, 4, and 5 feet. Okay, so now I have 5 feet here, and I want a bunch of 1/3 of a foot pieces. So I'm going to divide each of these feet into thirds. And you'll notice that within 1 foot, I have 3 1/3 of foot pieces. Each of these is 1/3 of a foot. So in 1 foot, I have 3 pieces. In each foot, I'm going to have 3 pieces. So these are all 1/3. I've just labeled them all here so you can see that each of these is a 1/3 of a foot piece of string. So let's look. How many pieces of string can I make? Well, in 1 foot, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I get 15 pieces of string. So how many pieces of string? 15. A whole number. Were you expecting that the quotient would be a fraction? Well, in this case, a good way to think about this is like you can think of many division situations. How many of the divisor can fit into the dividend? For example, if I think of some whole number division, if I'm doing 18 divided by 3, I can think of that as how many 3's fit into 18. 3, 6, 9, 12, 15, 18. 6 3's fit into 18, so 6 is the quotient. Another one, let's do 27 divided by 9 maybe. How many 9's fit into 27? 9, 18, 27. 3 9's fit into 27, so 3 is the quotient. It's a good way to think about this as well. How many 1/3's can fit into 5? Well, since 3 1/3's fit into 1 hole, I have 5 holes. That's why you might have seen this pattern. 5 times 3 is 15. That works because 3/3 will fit in 1 hole, and we have 5 holes, so each hole has 5/3. Each hole has 3/3 in it. 3, 6, 9, 12, 15. So I have 15 holes. So I actually get a hole quotient. Let's look at another related situation. Let's say I have 3 feet of string and I'm trying to make 1/4 of a foot sections. So my model will have 3 holes this time. And now each hole will have 4 1/4's in it. You're probably already coming up on the quotient in your mind. So one of the holes has 4/4, and I have 2 more holes. Let me label these. So I have 1, 2, 3, 4/4 in one hole, but I have 3 holes. So each of these holes is going to have 1, 2, 3, 4/4. 1, 2, 3, 4/4. So that's 4, 8, 12/4. So I can make 12 sections. 3 divided by 1/4 is 12. Okay, so far we've looked at these two equations where we take a whole number and we divide them by a fraction. But we can also look at situations where we start with a fraction and we divide by a whole number. What are we going to do there? For example, in this situation, there's 1/3 of a cake left over from a party. 5 people share the leftover cake. How much of a full cake do each of the people eat? So there's a situation that calls for this expression, 1/3 divided by 5 people. We're going to need a new model here because with our other equations, we started with a whole number. So we made a model of 5 wholes here and made a model of 3 wholes here. But we're starting with a fraction. So we don't even start with a whole. We start with less than a whole. That's important here. So I'm going to use our area model where this square represents 1 whole. In this case, the 1 whole cake. All right, but we only have 1/3 of that cake available that's left over. So I'm going to split the cake into thirds and shade in 1/3 of the cake. This is how much is left over. We can't look at this situation as how many 5s fit into 1/3 like we did with these. We thought how many 1/3s fit into 5, how many 1/4s fit into 3. That won't work here because 5 is much larger than 1/3. So in this case, we need to think of this as taking 1/3 and splitting it up further into 5 pieces. So if we start with 1/3 and we split it into 5 pieces, the resulting quotient, the pieces are going to be a lot smaller than what we started with, right? We only start with 1/3. So if we split that into 5 pieces, the pieces we split it into are going to be smaller. So our quotient here is going to be a smaller fraction than 1/3. What is it going to be? Well, if I divide this leftover cake into 5 sections, there we go, 5 sections, and then each person only gets to eat one of these sections here. What is that total fraction? How much of a whole is that? Well, it'll help for me to just extend these division lines all the way through the cake to make 5 rows. This looks a lot like our fraction multiplication, doesn't it? Our area models. And so now I see that each person gets one piece out of how many total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Out of 15. So 1/3 divided by 5, each person gets 1/15 of the cake. That's interesting. Did you notice this? 5 times 3 is 15, and 3 times 5 is 15. That is not an accident. That's one of those many patterns of math, and that will work for this equation too. If we swap the dividend and the divisor here, this one, 1/4 divided by 3, I bet you can figure out what that quotient is. Let's model it to see if you're right. So again, we're starting with 1/4, so that is less than a whole. So say again, this is our 1 cake, this picture here. But now I only have 1/4 I'm starting with. So I'm making 4 columns, and I'm going to shade one of them because I only have 1/4 of the cake to begin with. Now I'm dividing this 1/4 into 3 even pieces. This time I'm just going to go make these row lines all the way across. And then if one person gets that much of the cake, and how much is that? Well, that's 1 piece out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1/12. Did you say 1/12? Do you follow the pattern? 3 times 4 is 12, so 4 times 3 is 12. Well, there you go. That's how you can divide with fractions. If your dividend here is a whole number, and then you're dividing by a fraction, your quotient is going to be larger than the dividend you start with because you can fit a lot of 1/3s in 5. 1/3 is less than a whole, so you can fit a lot of those in 5. But if you start with a fractional amount, you're starting with less than one whole. So if you divide that further into 5 smaller pieces, the quotient is going to be smaller than what you're starting with because you're getting smaller pieces. Like here, we started with only 1/4 of the cake here, shaded in purple. We had to divide that into 3 pieces. Each of those pieces is going to be smaller than a fourth, end up being 1/12.